Alright, continuing where I left off. So when we deal with the Olagawa Aquifer, one of the reasons why the Midwest of the United States is considered the breadbasket of the U.S. is because of this Olagawa Aquifer. They actually have enough water that was easy to reach by well. So it was easy to irrigate, and so we could have these vast croplands, and we were able to produce tons and tons of food. We still are. There's still huge tracts of corn and wheat going across the Midwest. If you ever make the drive across the Midwest, when you reach places like Oklahoma and Iowa, you literally can drive for about 4 hours and just see cornfields, and that's it. So that's the aquifer. It is the largest one in the U.S. Now, also one of some of the real big ones that we deal with as far as water changes are dams. And basically, dams are anything that blocks the water flow of a river. And we use them primarily for hydroelectrics. It's a very clean method of getting electricity. We have over 45,000 large dams, so not little ones, but really actually very big. They're in hundreds of nations that have them. The very largest one is actually on the Yangtze River in China, and that is the Three Gorges Dam. That's the one that's actually shown in the picture here. It is 186 meters tall and 2 kilometers wide. And it actually has a reservoir, or the lake that's being held behind it is 616 kilometers. So it's this huge undertaking. It provides flood control, so you don't get as much flooding, and it allows for boats to pass through. But the biggest thing is it actually allows for a huge amount of electricity to be generated. So now when we talk about dams, there are a lot of positives. So we get a lot of power. We don't have emissions. We don't have power plants. It's clean energy. We get a lot of water there that we can use for crops. It gives us the water for drinking water. It stops flood control. So a lot of rivers have seasonal floods with the spring melts from mountains, and the dams actually control that. It allows for a lot of shipping to go back and forth across the large reservoirs, and you've got a lot of recreational activities. People can go boating and jet skiing and do all kinds of things on that reservoir that they wouldn't have been able to on a lot of the rivers there. However, we do have some drawbacks. You will find in environmental science there's nothing that is the quick fix. They all have negatives. It alters the habitat. We are driving animals and organisms. We're changing their habitat. We have a lot of fisheries decline. There's a lot of fisheries that really do need the river environment, and the reservoir just doesn't cut it for them. We push populations out of the way, so the people who lived behind where the dam was, they've got to move, otherwise they'll be underwater. It captures a lot of sediment, so rather than that sediment that comes down the river that's moving nice and quick, going all the way out to the ocean, it hits the dam and it slows down enough that it sinks. So the actual bottom of the dam actually ends up being kind of this silty sediment and slowly fills in. It does disrupt flooding, and that may seem like a positive. However, there are a lot of habitats that really rely on that seasonal flooding, that seasonal influx of water that no longer is going to happen. You always have the risk of failure. If the dam collapses, then you get a huge flood, even bigger than what the flood would have been initially, and it's not something that is like in season where you're kind of looking for the flood. It can happen at any point and be catastrophic. And the other big issue is not all of the dams, once you put the dam there and you start using the water, not all of them actually make it all the way out to the ocean anymore. The Colorado River is one of these. So much water gets used out of the Colorado River as it goes to hit the Hoover Dam that it doesn't always make it all the way to the ocean anymore. It actually dries up. So if you look, here is the graph of how much water is actually making it to the Gulf of Mexico, and there's quite a few days where there is basically no water making it all the way out. It actually is kind of like a dry ditch as it gets down to the Gulf of Mexico. It's changed a lot of the ecology. A lot of organisms that would have migrated can't get to migration spots because there is no river connecting to the ocean anymore. It kind of goes down from the Rocky Mountains and peters out and gets dry. So that's not terribly a nice thing. What can we do about it? One of the biggest things we can do is we can drop the amount that we're using for agricultural. The flood and furrow basically is where we dig the little kind of holes, ditches for the plants, and you spray a ton of water over them. About 55% of that water actually doesn't go to the plants we intend. We end up with weeds, we have overspray. A lot of that water is actually not getting into the plant. Some of it just soaks into the ground. The amount of irrigated land that we have has doubled in the last 50 years. We're eating more, there's more of us, and so we have a lot more cropland. When we over-irrigate, when we're spraying a lot more water, remember this water is being pumped up from underground, we end up having areas that are becoming waterlogged and getting salinized or having too much salts and minerals in them because this isn't rainwater, this is water pumped up from the ground, so it has all these minerals dissolved in them. Which then causes farmers to lose income, and so they increase the amount of farmland so that they can kind of maintain their same quality of life. Most national governments subsidize irrigation. It's cheaper for a farmer to do a wasteful irrigation than it is for them to conserve. One of the solutions is if you have canals lining them so all the water's not just evaporating. Using low pressure spray irrigation, so it's only spraying the water down, it's not spraying it across vast areas where a lot of it's getting evaporated before it even hits the ground. Doing drip irrigation, so individual plants are actually getting the water and it's not going everywhere. Also matching crops to the land, growing crops that would normally grow in that type of environment. This causes some issues because demand is for these high water loving plants, but there are a lot of plants that are edible, that are good foodstuffs that can do with less water. We just don't consume a whole lot of them. Also doing selective breeding and genetic modifications to need less water for the plants that we do tend to like. One of the other things that causes a lot of water, which we've heard in California, a lot of uproar about, is the residential demand, where they have the water rationing. And basically this is not using as much water in your household. Having low flow toilets, having the low flow shower heads and washing machines, ones that don't use the same volume of water. Not watering your lawns during the day, watering them at night so that the water's not just evaporating as soon as you spray it out on the hot ground, watering it at night so all of the water actually gets into the grass. You can eat less meat because the cattle have to be watered, they eat a lot of grass. If you eat less meat, we use less water. Xeriscaping, basically landscaping using plants that are adapted to their area. So rather than being in the desert and having a nice pretty grass, have a cactus garden, have a garden of plants that are able to deal with having less water. Also, we can reduce the amount that industry uses. Industry is a huge consumer of water, and basically this requires the engineers to come up with processes that we can do the same tasks for manufacturing but with less water. Recycling the water, so if we used it once, reuse it. It's not being consumed. If we're using it for cooling, keep using the same water, condense it down, reuse it. Not allow for surface water runoff. Use like the rainwater from the roofs and from the roads to recharge their water that they're going to be using. Patch leaky pipes. It's amazing how much water gets lost just because the pipes leak and nobody's fixing them. Audit the industries, make sure that they know how much water they're using, and kind of promoting them to think about it and try and come up with some alternatives. So there are not just ecological concerns when we talk about water conservation. Basically, in order to have water be conserved, we have to hit people in their pocketbooks. That's what causes change, is if it costs you money, you hesitate. And some economic approaches to causing water to be conserved are stop having the government pay for inefficient practices. Stop the subsidies, because the government pays out money to help support farmers, and if they stop kind of supporting that and let the price of water reflect how much it's actually costing instead of taking a chunk of that and having the government pay for it, then the farmers and industry is going to be much more aware and cost cutting of how much water they use, because it's going to cost them more money to use more water. Industrial uses tend to be more profitable than agricultural. What the problem is globally here is if you are in a less developed country, they suffer. You have a lot of famine because the water that would have been used for agriculture is now going to industry if they have a limited amount of water in the area. And manufacturing makes more money, so we have a chunk of the population starving because they don't have water to irrigate their crops. Privatized water. This is one that's been very heavily promoted, especially in the southwest of the United States, is basically having, instead of the government running the water supply, have it be a private company that you're buying the water from. And the thought process here is a private company is going to be much more efficient. They're not going to have as much bureaucracy. But the problem is that a private firm is not going to have much incentive to make sure that the poor and the less privileged have adequate access to water. So it's kind of an iffy thing. It may promote conservation within businesses, but it's not going to do real well for those who are the higher needy in our society. Also, having, instead of water control being controlled nationally, having the water control be locally, so at kind of the county level, instead of it being the entire state, having it kind of be a county level who's got control of the water, because that way local communities will be able to see, hey, we have enough water, or we don't have enough water, and kind of self-police in that matter. Alright, now one of the last pieces, which kind of leads us into the next topic, which is soil, is when we have a lot of irrigation going on, we get salinization. And basically, heavily irrigated soils that get a lot of water that's being dumped on them, and that water is coming from groundwater, they have a lot of salts and minerals dissolved in the water because it's coming from down under the rocks. Well, as that water goes down and the water evaporates, the salts and the minerals are left behind, and as those salts build up, think of osmosis, water goes towards where there's more stuff, and instead of water going into the roots of plants, the water actually will stay out where there's all the salt and minerals out in the soil from the evaporated irrigation. And basically what happens is this effect inhibits about 20% of growth every year, and there's not much you can do about it. We can prevent and not do huge water guzzling crops in sensitive areas. Make sure you have low salt water, filter it first. Irrigate efficiently, only putting enough crop water that the crop needs, using the drip irrigation, etc. Prevention is really it. To try and remediate or fix it becomes very, very expensive. Basically what you have to do is put tons and tons and tons of water until all of the salts leach all the way down through all of the soil back down into the groundwater. And that takes huge amounts of water, and it's not terribly effective because it washes all the other nutrients out that you want in your soil as well. And so that's kind of a problem. So that's with our soil salinization. And this kind of takes us into soil, which we'll get into next time.